Hello and welcome to our notes online. So this is Miss Hoig and you guys are going to be taking a look at the 812, 813 notes. We started these on Friday, March 13th. So if you were not here, go ahead and keep listening to this video. But if you were in school and you feel comfortable with what we covered on Friday, go ahead and jump to the next video. Here we go. So 8-13, we are looking at this generic rectangle. So we are supposed to review what we learned in 811 by writing the area of the rectangle at right, okay, well it's on the left, as a sum and a product. So in order to write my area as a sum, that means I need to add up anything inside. Sum means add. So if I write my area as a sum, I need to remember that that's also standard form. So for this example, it looks like, well, there's only one x squared term, that's 10x squared, and then plus 30, oh, excuse me, okay, those are both negative, so actually that's going to be minus 39x, and then plus 14. Cool, so there's our standard form. And then for my factored form, I have to go in and look at the rows and columns on this problem. So, okay, well, the greatest common factor of this row here is going to be 7. This one, it's looking like it's going to be 2x. This column here is going to be 5x. And then this one at the end is going to be 2. I need to double check and make sure everything does multiply in. So does my 7 here and my 5x here actually multiply to my negative 35? No. So I have to go back and add in this negative term. Technically, this would still work if you made the 2x and the 5x both negative, but it's best practice to put the negatives with that constant term at the end rather than the one with the x. So there are our two factors, the length and width. So when we write this as our product form, that's the big money here. That's going to be our factored form. So you are entering into the world of people that factor, which is super exciting for you. And you probably won't realize how significant this is till later, but hey, you can still celebrate. Okay, so, oops. All right, so my factored form here is going to be my length times my width, 2x minus 7 times my 5x minus 2. And that is, okay, so let's just take a look. This and this, those are the same function, or that expression would represent the same thing on a graph. They're both parabolas. This is just two different ways of writing the exact same thing. So this part and this part, those are the same exact mathematical concept. This is, the second one is just written as a product. It's just like writing 2 times 4 instead of 8. It's the same thing. So that's just something that we're trying to learn here. Most of you guys, your parents have not learned factoring with this square, the generic rectangle. So if your parents are trying to help you, they might be confused. They might be using the term FOIL. I would just encourage them actually to jump on here and just watch this with you so then they can be down with Get Down. So here we go. Moving on to part B. So does the generic rectangle fit Casey's pattern for the diagonals? So if you remember on 811, Casey's pattern was that the diagonals do multiply to the same number. So it says demonstrate that the product of each diagonal is equal. Okay, well, I'm going to show my work because it's math class and I am an A student. So I'm going to multiply my first diagonal that I see here. I'll do 10x squared and 14. So 10x squared times 14 is going to be 140x squared. And then if I take a look back at the other diagonal, I'm seeing a negative 35x and a negative 4x. So I'm going to do negative 35x times negative 4x, and, well, 35 times 2 is 70, and two 70s together would be 140. Two negatives make a positive. I got my 140x squared for both. So happy. All right, so there's 8-13. 8-14. We got, all right, so we have another expression. So remember, if you were to graph this thing, this would look like a parabola on the graph. So we are not doing that right now, but that would be future. So we are supposed to use algebra tiles in order to write this as an area and a sum. So we don't have our algebra tiles, darn it. So I have to imagine, well, if I have 2 squares that are x squareds, and then I have 5 squares that are just the x's, and then I have 3 1 tiles, how could I make this an exact rectangle? So let's see here. I think I can use this guy. So I would have my 2x squareds like that. And then, well, let me think here. If I put an x tile here and an x tile here, and an x tile here, well, I could put a little 1 tile right there. Well, I have 5 x tiles that I have to use. I'm using 3 so far, but I need 3 1s, 1, 2, 3. So wait a second, if I put 2 x tiles here, these could be 3 little 1 tiles right there, and I'd be good to go. So my dimensions on making a generic rectangle here would be, across the bottom we have 2x plus 3, and along the side here we have x plus 1. So my product, my dimensions would be x plus 1 and 2x plus 3. Product x plus 1. Willet, what are you doing? Sorry, my dog is licking the carpet and it is so loud and disgusting. Okay, so we have 2x plus 3, x plus 1, and then the sum, or the standard form, would be just anything in the middle that I added up. So I have my 2x squareds here, so 2x squared. I do have 1, 2, 3, 4, 5 x terms, and then my plus 3 at the end. So this is really good because these do equal the same thing. I used all of my blocks, and this demonstrates the process of factoring, which is like this huge, huge thing in math. Welcome to the factoring world. Tra-la-la. Okay. So let's go down to the bottom one. So the last exploration thing we're going to do here before I teach you how to factor, just kidding, second to last thing we're going to do before I teach you how to factor start to finish, is we're going to take a look at this generic rectangle. So let's just say that we jumped into a factoring problem, which you're going to learn in a little bit. And what we have so far is the 2 diagonals set up for a generic rectangle. So because of Kelly's thing that she keeps doing, we know that these 2 numbers have to multiply to 24x squared. Got it. Well, that means that the missing ones also have to multiply to 24x squared. So that's kind of the first sentence on this problem. And then it says we have to find 2 terms that would complete the generic rectangle, and then we have to write everything as a area and a sum. So, or product and a sum. So here we go. If I think about 24x squared, I'm trying to think of 2 terms that multiply to 24. All right, I can think of 2 and 12. So like 2x and 12x. So if I were to go ahead and just put those in here, 2x, 12x, I could finish this off and be like, okay, well, well. GCF of 2x and 8, I'm thinking a 2. And then the GCF of 3x squared and 12x, we got a 3, and we can take an x out. And here's our x, and then we would have our 4 right here. Love it. So our product of this generic rectangle would be I'm going to talk a little less because my voice is apparently a sleep song for some of you. So I'm just going to take a moment to write out my product form in silence so you can too. I'm not salty, you're salty. Okay. And then for our sum form, well, remember our sum form is standard form. So if I write my area as a sum, or the solution after I add all of my terms up that are in the middle, well, I get 3x squared plus 14x plus 8. So again, that's just writing the same area either one way as a sum and one as a product. So we've done that actually 3 times in a row here. We did it up here when we said the sum and the product form. Then we did it here, the product and the sum form. We did it one more time, product and sum form. So just notice that we are just jumping between those two here. All right, so I'm going to do one more video of stuff that we did on Friday, and then the third video that's going to be up here will be starting off on material that nobody has seen yet. Okie dokie.